Greetings all. My name is Lena, and today we would like to present to you our project evaluating the smart luggage handling system through modeling and simulation. We are all delighted to take you with us on the journey of the project. Our journey will be in 5 sections. I will start by the introduction. My friends will explain the system design and implementation, experimental design, result and discussion, and finally, I will end the project by the conclusion. I will start off by the traditional luggage handling system procedure. When talking about the luggage handling system procedure, it's the procedure of bags entering and leaving the system from either landside or airside, where the landside is open area to the public and airside includes all parts of the airport around the aircraft. There are 4 different luggage handling processes: check-in luggage handling, outbound luggage handling, transfer luggage handling, and finally we have the inbound luggage handling, which is our main concern in this project. It is the process when the luggage from the coming flight is going to be brought to the in-feed station, and, by the traditional luggage handling system, they will be sent to passengers in the conveyors, so they get to reclaim all their luggage from the reclaim area. As we all know, the inbound traditional luggage handling system is an important part of the operations of the airport terminals. With that being said, there are several problems with the current inbound luggage handling systems. They are slow as the bags do not arrive at the luggage conveyor before the passengers do. Doesn't let people know when the bags are arriving. So, due to the importance of the luggage handling system, the smart luggage handling system was proposed with the goal of minimizing the possibility of mishandling bags. It also has the potential to improve airport operations by providing better planning for the inbound luggage handling process to enhance the travel experience. However, the airport system involves several complicated interrelationships subsystems, so performing the physical experiment would be extremely costly and challenging. With that being said, simulation modeling provides an efficient and practical approach, where in our case, Flexim software tool was used in this project. Moving on to the project objectives, which are: chose a 3D simulation modeling and analyzing tool, studied and collected traditional luggage handling system data, designed and built a simulation model for both the traditional and smart luggage handling systems, and finally evaluated and testing the simulation model's performance. And now, my friend Nov will explain the system design and implementation.
Thank you, Lena. So, the main idea of the smart luggage handling system is to hide the mechanical parts, which are the conveyor belts. They will be moved to the back end, so what become in the front end are the gates. They are the interface between the system and the passengers. The communication between the system and the passengers will be through display screens or mobile application. Coming to how SLHS works, first, the luggage will be unloaded into conveyors. The RFID tags will be scanned, then the system will sort the luggage in a group of parties. Then the luggage will be moved to the collection points. To pick the luggage from the gates, the passenger already has an ID that matches the RFID tags on their luggage. So the system should send a notification to the passenger when their luggage is ready to be picked up. Moving to the components of SLHS, first, the RFID tags. It matches the passenger with their checked luggage by putting tags on them. The inline scanning device, it reads the luggage item's information by scanning the RFID tags. The conveyance mechanism, where luggage will be transported on the conveyors. The sorting points allow the items to either continue traveling on the same level or move them to a subsequent level. The secured collection points are the secured gates to which the system ejects the baggage items. Lastly, the superordinate control system. It defines the path each baggage item is to take, and it controls all the sorting points. It also notifies the passengers and airport staff of missing items. Moving to the conceptual design. In the conceptual design model, we have 6 inputs for the luggage handling system simulator and 3 outputs of our system, as shown. Going through benchmarking SLHS, we identified and adapted the best practices to help us improve the smart luggage handling system's performance. For the comparison to a traditional luggage handling system, where we chose King Khalid International Airport Terminal 5 to establish the performance goals with standards and measures that would be considered a performance benchmark. We benchmarked the SLHS through the simulation model against the TLHS simulation model and analyzed the results of different system performance measures. Moreover, to improve the efficiency of SLHS, we optimize the number of input streams, levels, and output streams to ensure the minimal delivery time for passengers, clusters, and flights. Now, my friend Haneen will continue with you with the experimental design.
Thank you, Nav. The experimental design will view the parameter settings, which consist of the experimental variables and the procedure experiments on them. Then we will discuss the set of the performance measures. The provided table shows summary of the model's default parameters. The following set of performance measures are the passenger delivery time, which is the waiting time for passengers to have their luggage cluster delivered. We calculated the average, minimum, and maximum time. The cluster delivery time, which is the time for each cluster to be delivered. We calculated the average time. The flight delivery time, which is the time for each flight to deliver all luggage. We calculated the average total time. For our findings and results, it describes the experiments intended to demonstrate the model's effectiveness and reliability in supporting real-world luggage handling systems. The experiments are performed using different number of flights and passengers per flight, and manipulating them as an input for the model. We tested the same scenario, but for different smart luggage handling system levels. We chose level 5 and 7 in our experiments. The experiments were conducted to demonstrate the developed smart luggage handling system and the traditional luggage handling system using the three performance measures described previously: the passenger delivery time, cluster delivery time, and finally the flight delivery time. Our first experiment chose the minimum, average, and maximum passenger delivery time in minutes to benchmark the smart luggage handling system. In summary to what we have seen in our results, it gave us exciting insights that we would love to point out. First, the traditional luggage handling system, average and maximum delivery time increased noticeably when having more passengers. As you can see, the bold color, which represents the traditional luggage handling system, will have a significant increase compared to the smart luggage handling system. We believe the reason is behind the conveyor structure, where in the traditional luggage handling system, all luggage goes through the same path, resulting in overcrowding the system and decreasing the chance for a passenger to have the luggage closely lined up together. Also, changing the number of flights shows the smart luggage handling system efficiency. As in the model, all luggage will enter in one path, but the system handled it efficiently. And now, my friend Esma will complete with you the rest of our performance measures.
Coming on to the next performance measure we have is the cluster delivery time. After reviewing and analyzing the results, we got the following discussions. These figures illustrate what we have seen for both levels. We noticed that the jump in the time between a passenger having cluster 1 and a passenger having cluster 2 in level 5 and level 7 for the smart luggage handling system. And we believe it is because when the passenger has more than one luggage item, the cluster's average will be affected depending on the distribution of the passenger's luggage. The first figure illustrates when we have 32 passengers. It shows that both levels have similar waiting time for cluster 1 and cluster 2, but as the cluster size increases, level 7, which is the dark blue line, took much more time than level 5. While the second figure we increased the number of passengers to 128, it shows that as the cluster's size increases, level 7 took less time compared to level 5. So we can say, when minimizing the number of levels in smart luggage handling system, it will be highly affected by the passenger's capacity as we increase it. Finally, we conclude that having the smart luggage handling system with a minimum number of levels, such as level 5, will suit a minimum number of passengers and flights, and vice versa. Last performance measure we have is the flight delivery time. It showed the efficiency in total flight delivery time for the smart luggage handling system compared to the traditional luggage handling system. The results had major differences with more than 10 minutes apart, as it may be half of the time needed in the traditional luggage handling system. These two figures shows the jump when we set the passengers to 128. We believe that this jump is because of the conveyor structure, where all luggage in flight goes through the same path, resulting in overcrowding luggage and an increase in the number of luggage that needs to be rerouted in the smart luggage handling system. Whereas in the case of the traditional luggage handling system, the jump is less clear since each flight will enter the conveyors independently.
Finally, our goal was to model and evaluate smart luggage handling system and benchmark its performance against traditional systems. Although Although this project has successfully achieved the main objectives, we are looking forward to future work, which consists of finds greater and real data and experimented with, operates more levels and tests for larger passengers, extend the project for more features. And now we are at the end of the journey, but before that, we would like to thank you for this opportunity. Also, we would be delighted to present to you the smart luggage handling system and the traditional luggage handling system models in the provided links. Thank you.